Okay, so the lesson that we were moving on to in your workbook in the unit on relations and functions, it is lesson 3, which is on page 413. So if you could turn to that page, what we're going to do is it starts off with just doing a really quick review. But before we fill in the blanks, let's draw ourselves a Cartesian plane. And let's write a few things that we learned last class in lesson 1 and in lesson 2. So if you have yourself a Cartesian plane, label your two axes is always the first step. So that's your y-axis, and you stab your x through the heart. And then I want you to, they're going to be asking about independent, dependent, input, and output. So if you could label your I, V, D, V, input, and output, just to see if you have that memorized. What it should be is your x is always the input, and it is the independent variable. The y is always what's output, and it is the dependent variable. The y coordinate depends on whatever you input for your x value, okay? And then remember, the last thing is we have something called an ordered pair, and ordered pairs are x comma y. All graphs are relations. So all graphs are going to be what we call relations. And a relation is representing two sets of data. And we always represent those two sets of data with an ordered pair, our x and our y. So those are our two sets of data. So it says a relation is a connection between two quantities. A relation can be represented graphically by a set of ordered pairs. So with every relation, we could represent that data as an ordered pair, and then we can further plot that data. So then what it says is it says the first component of the ordered pairs would be that component there, which is our x coordinate. And the x coordinate is also known as the input, it says. Values of the input are values of the independent variable. So input and independent variable. The second coordinate would be, or sorry, the second component, this is the second component of a set of ordered pairs, is the y coordinate. It is also known as the output. Values of the output are values of the dependent variable. Okay, so that is going to be your review. What this lesson is on, so this entire lesson, it's not, like I said, a long lesson, it is on X and Y intercepts of a graph. So finding the X and the Y intercepts. Here we're going to find the X and the Y intercepts graphically by looking at a set of graphs. And then what we're going to do is we're going to do what's more important for this unit, and it's finding them algebraically. So this first one here, what it says is it says, list the coordinates of the points where each graph crosses the x-axis. So remember, like, these are your x-axes here. So the x-axis is always this horizontal axis. So that's your x-axis. And what it says is graph 1 crosses the x-axis at. So this is your x-axis. Put a dot on your x-axis where the graph cuts the x-axis. And that coordinate is -3, 0. Okay. What I want everybody to do now is graph number 2. It says it has 2 coordinates on the graph that cut the x-axis. So the graph cuts the x-axis at that coordinate and at that coordinate. So I want you to write those coordinates. And this is graph 3, and it has 2 different coordinates that it wants you to figure out, here and here. So what are the ordered pairs that represent those x-intercepts? Okay, so crosses the x-axis. Okay, you could check your work with mine. This ordered pair would be -2, 0. And this ordered pair, some students say it's 2, 0. It's not. This guy's at 3, 0. For this graph here, this is -2, so that's -4, 0. And this graph, the X-intercept, the ordered pair, is at 4, 0. Okay, so what you need to notice here, so this is like the big takeaway from this, is they're going to say to you, okay, what do all of these points have in common? And what I'm hoping you notice is all of these points, which were X-intercepts, Y is equal to 0. So what happens is if ever I ask you to solve an X-intercept, you are always going to let Y equal 0. So an X-intercept is always going to be whatever the X value is, but this Y will always be 0. So if I give you, without plotting, let's say I give you -5, 0, and I say, what is this point? You would say, this is an X-intercept at, and then I'll say, what's the X-intercept of this graph? X is equal to -5. Because all X-intercepts, Y is equal to 0. Okay? Okay, C says list the coordinates of the points where each graph crosses the y-axis. So I'll do this in a different color. I'll do it in blue. So in graph 1, I want you guys to figure out what that ordered pair is, because that's the y-axis, this is the y-axis, and this is the y-axis. In graph 2, it's that point right there. And then in graph 3, it would be this point and this point. There would be 2 y-intercepts in graph 3. So if it cuts the x-axis, it's called an x-intercept. If it cuts the y-axis, the point is called a y-intercept. So get those 4 points, these 4 here. This first one should be simple, 0, 5. So double check that you had 0, 5. This second one, that ordered pair there is x is 0 and the y was at 6. So hopefully you were able to see that it was 0, 6. For the circle graph, there was 2 y-intercepts, 0, 4 was the top one, and 0, -4 was the bottom one. Again, what was the takeaway? So we were looking for y-intercepts. And what hopefully you noticed, all of these ordered pairs were y-intercepts. The x value is always going to be equal to 0 on a y-intercept. So it is always going to be x is 0 and then whatever y is. If you see this guy, this coordinate here is going to be a y-intercept. Okay. All right. Flip your page. And I believe that there's only 2 class examples that we're going to do, and then I will, I'm going to do one with your homework just so that we've got 3 done at least. Okay, so scroll down on your page to page 414, and what it gives us is it gives us the equation of graph 1, and they said the equation of this graph is as follows. 3y is equal to 5x plus 15. Right now, you guys are not able to punch this in on your calculator. And in a later lesson, I will teach you how we would punch this in. But the reason why we can't punch this in our calculator right now is because on your calculator, you can only punch things in if your equation is written in the form of y is equal to, and right now there's a 3 in front. So in later lessons, I'm going to show you how we get rid of that 3, and it's going to be super simple. You're going to say, okay, to get rid of that 3, we've got to divide that by 3, right, to get y by itself. If we divide that by 3, what we will do later on is we will divide each term on the other side by 3. But that's just sort of where we're going to be going. What we're going to be doing right now is we're going to be solving the x-intercepts and the y-intercepts. So here's what I do, is underneath x-intercept and underneath y-intercept, always write the equation that you're given, the original equation. So 3y is equal to 5x plus 15. And then again, I'm going to write it over here. 3y is equal to 5x plus 15. Okay, if I ask you to solve for the x-intercept, what you are always going to write is you're going to say you're going to let the other letter. So if you're solving for an x-intercept, what you're going to do is you're always going to let y equal 0. So if you're solving for an x-intercept, you're going to let y equal 0. If you're solving for a y-intercept, you're always going to say, okay, what's the letter other than y? It would be x. You let that letter equal to 0. And this is how we're going to, so there's that word algebraically determine the x and the y-intercepts. Okay, so the x-intercept, we're going to let y equal to 0. So let's take this out, this y, and let's put a 0 in. 3 times 0 is equal to 5x plus 15. 3 times 0 is 0 is equal to 5x plus 15. What we have to do is, the reason why we let y equal 0 is now I just have x. I need to somehow isolate this x, and then I have the x-intercept. So I need to get rid of this plus 15. So I'm going to subtract 15 from both sides. And I'm going to have negative 15 is equal to 5x. Let's isolate x. It's being multiplied by 5. Divide both sides by 5. The x-intercept of this graph is negative 15 divided by 5, which is negative 3. What you always must do once you have an intercept is you must always write, well, what was the ordered pair? So x is negative 3. And what was y? If it's an intercept, y is 0. Negative 3, 0. Okay, now let's take that exact same equation and algebraically solve the y-intercept. So to solve the y-intercept, we are going to let x equal 0. So whenever you see an x, take that x out and put 0 in. So 3 times y is equal to 5 times 0 plus 15. 3 times y, anything times 0 is 0. 3 times y is equal to 15. And what we are doing is we're isolating for y. So divide by 3, divide by 3. The y-intercept is equal to 5. Once you have the intercept, you always give the ordered pair. So the ordered pair, y is 5. What was x if it's an intercept? Oh, the other letter is 0. Okay, what the interesting thing that we could do from here is as follows. You actually only need 2 ordered pairs in order to be able to get your graph. So I know you guys don't have much room, but just on the left-hand side, I want you to draw a little Cartesian plane. And let's plot negative 3, 0. So x is negative 3 and y is 0 is that point right there. That is my X-intercept. My X-intercept is at -3. Then let's plot this point. X is 0 and Y is 5. So here's X is 0, Y is 5, which is right there. I'm going to plot that point. As long as you guys have two points, and in this case it's two intercepts, you are able to get the graph of this linear equation. So your graph must go through those 2 points. And this is what your graph would look like. And actually, I'm going to take it one step further, and I'm going to show you how we would enter, because I believe there's going to be a fraction on your calculator, how we would enter this on your calculator. So this is just taking it one step further. So I just want, you could just watch up here, or if you want to enter this with me, you could. So remember I said that the equation was, they gave us the equation of 3y is equal to 5x plus 15. I just want to show you how you would enter a fraction on your calculator. We can't enter anything on our calculators unless we have to hit y is equal to, right? Like we just have to isolate y. So we are unable to graph right now unless we get rid of that 3. So this is going to be much later that we're going to do this. But what I'm going to say to you is I'm going to say, okay, you guys, how do we isolate this y? How do we get rid of this 3? And you'd say, oh, we divide that by 3. And then I'd say, perfect. What you do to one side, you do to the other side. If there's more than one term, you divide each term by 3. So now what I have is y is equal to 5 divided by 3, x plus 15 divided by 3 is 5. So we entered this into our calculators in lesson 2, but we never actually entered fractions. Just like when we were doing math, and I was teaching you guys how to enter fractions on your calculators, you always enter a fraction in a bracket. So even though it's 5x divided by 3, I want you to enter that, like visualize this as 5/3 x plus 5. So if you want to enter this with me, we'll take out our calculators. And you would say, okay, open bracket, 5 divided by 3. You would close that bracket and put an x there, and then plus 5. If I graph this, my y-intercept is at 1, 2, 3, 4, 5, which is what we had. And my x-intercept is at -1, -2, -3. So it's exactly what we had. Okay. Okay, for class example number 2, I don't like the one that they gave you because they gave you squares, and that's what you're going to be doing in 20-1. I'm going to give you a linear equation. So can you guys please cross this out? And in its place, I want you to write down 2y plus 3x minus 12 is equal to 0. So again, later on, I'll show you how to enter this in your calculator because we'd have to totally isolate this y, right? So we'd have to get rid of that 3x and get rid of that -12, but that's actually a different chapter. That's our next chapter. So right now, based on this equation though, you could calculate your x-intercept. How you do that is you let y equal 0. So you take your equation, which is 2y plus 3x minus 12. And in this, they want the x-intercept. So I'm going to take out this y and I'm going to stick in a 0. So 2 times 0 plus 3x minus 12 is equal to 0. Now, 2 times 0, I don't even need you to write 0 underneath. Right? You could just, I'm fine if at this step you just get rid of that because 2 times 0 is 0. So what we are left with is 3x minus 12 is equal to 0. Okay, you need to algebraically solve and you need to isolate this. Get rid of that -12 by adding 12 to both sides. 3x is equal to 12. Get rid of the 3 by dividing it out. X-intercept, because that's what we were calculating. 3 divided by 3 cancels. I've got X by itself. 12 divided by 3 is 4. Whenever we do intercepts, always give the ordered pair. The X-intercept is 4. What did we say Y was? Well, Y was 0. Okay, Y-intercept. If you were solving for a Y-intercept, you let X equal 0. So always write out your original equation. 2y, so I'm just going to move. Okay, 2y plus 3x minus 12 is equal to 0. So always write the original equation as your first step. Second step is take out that x and put in a 0. Anything times 0 is 0. So 2y, normally we would have like plus 0 minus 12, but that's just the same thing as 2y minus 12 is equal to 0. We need to isolate this. So get rid of that negative 12. How do you get rid of a negative 12? Add 12 to both sides. Y is being multiplied by 2. The opposite of multiplied by 2 is divide by 2. Y-intercept is equal to 6. So that's my y coordinate is 6. What was your x coordinate? It is 0. Once you have your x and your y-intercept, you could sketch a little tiny Cartesian plane. X is 4, y is 0. Would be that point right there. X is 0, y is 6. Would be this point right here. Once you have your 2 points, you've got your graph. So once you have an x and a y-intercept, you then have your graph. I put arrowheads at each end to show that the graph goes forever in both directions. Okay, so that is how you algebraically solve an x and a y-intercept. And that's all this lesson is on. We are not doing class example 3. We will do that in a different lesson. So now I'm going to give you your homework. Okay, so determine the value of the y-intercept. Okay, so what I want you to do is I want you to circle number 1, but I want you to cross out these 2. Because I won't give you guys quadratics. Now, in this example here, in class example number 1, they only want the y-intercept. So what you're going to do for this class example is you're going to say, okay, let's let, if they want the y-intercept, we let the other letter equal to 0. So in this equation here, I'm going to take this x out and I'm going to put in a 0. Y-intercept is equal to 0 minus 5, which is negative 5. And then give me that as an ordered pair. So when y is negative 5, x is 0. Okay, so for all of these, wherever you see the x, you are simply going to put in a 0. And you are going to isolate and solve for y, right? So if we were doing d, like let's just quickly set up d, this would be 0.5 times 0 minus 2.4 y plus 0.8 is equal to 0. Anything times 0 is 0. So negative 2.4y plus 0.8 is equal to 0. We got to get this guy by itself. So get rid of that plus 0.8. Negative 2.4y is equal to negative 0.8. And then divide both sides. Remember, some students will say they want to add 2.4 to both sides. No. If it's negative 2.4 and y is next to it, there's a times there. So the opposite of timesing by negative 2.4 is dividing both sides by negative 2.4. And then you will have your y-intercept. Okay, so I want you to do number 1. I want you to do number 2. And for number 2, cross out E for me. And then just sort of make note. I'm just going to erase this for a second. Please make note is all they want you to calculate in number 2 is the X-intercept. So what you do here is you let the other letter, which is y, equal 0. So in this equation, y comes out, 0 goes in. We have to solve for this x. I got to isolate this guy. How do you get rid of a negative 2? You add 2 to both sides. And the x-intercept is equal to 2. That ordered pair would be 2, 0. So I want you to do question 1. I want you to do question 2. For question 3, these are the ones that I want you to do. A, B, C, and F. And what it's saying to do here is determine the X and Y intercepts. So how we did this is we split this sort of in half, X-intercept, Y-intercept. When you're solving an X-intercept, let Y equal 0. So write down the equation. And then take out your Y. And if I'm solving an X-intercept, I got to let Y equal 0. And then remember, we want to isolate this X. So get rid of that 7. And I got negative 7 is equal to 4x. Get rid of that 4. The X-intercept is negative 7 over 4. And just let me quickly look in the book if they keep it as a fraction. So they do in their book keep it as a fraction, and then they say, okay, it's negative 7 over 4, 0. On a test, I'll tell you right now, I'm totally okay if you convert this to a decimal. And the reason is if I said, well, where is negative 7 over 4? You need to know what that decimal is before you could plot it. So if you typed in negative 7 divided by 4, that intercept is at negative 1.75. It's not quite at negative 2, but it's close to negative 2. Okay. For this side, when you're doing the y-intercept, remember you let the other letter equal 0. So let x equal 0. Write down your original equation, 4x plus 7. Take out your x and put in 0. Anything times 0 is 0. The y-intercept is equal to 7. That ordered pair would be this. You do not have to graph. So it just wants you for number 3 to do, can you find both intercepts? So I want you guys to do those guys. And then Just seeing if there's any multiple choice that are good questions. Okay, the last one that you could do is question 8. We'll do these ones later when I want to do tomorrow's lesson first before we do those. Okay, question number 8 is your last one on X and Y intercepts. So what it says is in which of the following relations does the graphs of the relation have the X and Y intercepts with equal values? So what they're saying is, like, for this equation here, y is equal to x plus 8. It wants you to find both the X and the Y intercept, and one of these are going to have the exact same X and Y intercept. So for example, for this one here, if I calculated the X-intercept, I would let y equal 0. I know that the X-intercept, if I get rid of that 8, is -8. If I was doing the Y-intercept, I'm going to let x equal 0. So y is equal to 0 plus 8. That would give me a Y-intercept of 8. These are not equal. The answer is not going to be A. So you guys check B and check C because it will be one of those. And I know you could easily just look at the back of the book and see what the answer is, but this is how questions are going to appear on the test and how to algebraically solve them. So make sure you're able to do each of these. Okay. So that is it for today's lesson. It is just on, do you understand X and Y intercepts? And if you understand that, you could do those 3 questions plus question 8, so 4 questions total. And I will let you guys sign off if you want. I will be on probably for the next 10-15 minutes. Okay, I'm just going to stop recording.
Miss King.